before I get started, I have a couple of disclaimers I have to make. The first one, and you probably think it's a joke, but it's not. I'm legally required to tell you that the views expressed in this talk are not shared by my employer. In fact, they don't share them or even barely tolerate them. I actually have to state that. The second thing, not legally required, but maybe more important, it's not going to be a talk on OCaml. It's going to be a talk on Scala. So, oh wow, there's actually people who like Scala, because I was thinking I'm going to be very lonely out there. Everybody's going to hate this. So this was initially supposed to be for a Scala conference. I adapted the code a little to shield you from the more extreme examples of our delightfully quirky syntax. It's still Scala though, so everything's going to be fine. I'm going to walk you through the code. It's going to be all right, but it's still Scala, so I can't really change that because capabilities are Scala thing. Right, okay, so I'm talking about capabilities. And the first problem with capabilities is deciding what they're used for, because it is a Scala community, so everybody has a different idea. Not everybody agrees on it, but in the massive Venn diagram of what people think they do, there's one thing that always comes up in common, so I'm going to talk about that. It's direct style. Apparently, capabilities allow us to use direct style, which is a great answer if you know what direct style is. I did not know what direct style was, so I had to look that up. And I pieced together the following definition. A direct style of programming is one in which control is passed implicitly from one line of code to the next and is opposed to continuation passing style, or equivalently monadic style, where it's made explicit by a continuation. More or less, I don't know. Honestly, it took me a while to process that one. We don't have a while here because they're very strict about timing, so I came up with a different definition, which I think is clearer and in the context of what Scala is trying to achieve, no less correct. A direct style of programming is one in which you can write code without faffing about with monads. Now, some of you are probably thinking, hang on a minute, that looks a lot like the kind of code I used to write before I studied category theory and ascended to a higher state of consciousness, and you're absolutely right. I'm talking about imperative style, but part of what I'm going to try to achieve here is to show that while imperative implies direct style, the converse is not true. And I'm going to do so by writing a very simple program that is very imperative and then tweaking the code little by little until I remove a lot of the properties we dislike about imperative style. And that's where the magic bit is going to be. In the end, the code is going to be the same one as the one we started with, at least at the term level. I'm going to change the types, but the terms won't change. And so I will consider that a proof that you can have direct style without some of the quirks of imperative style. Now, in order to demonstrate that, I am going to write a simple bit of code that we're going to transform together. It's something most of us have written at some point. It's the guess a number game, right? It's the game where I come up with a random number. You have, between 0 and 10, you have, say, 3 attempts to guess it. And every time you guess wrong, I'm going to have to tell you whether or not whether it was too high or too low. It's not a fun game on a scale of the best time ever to, oh my God, make it stop. It's roughly a Rubik's Cube. But it's simple enough and not too simple for our purposes. So this is where the Scala code starts. The first thing I'm going to do in order for that to work is to be able to read your input. I'm not going to do anything fancy here. So I return an option of int. No specific error handling. I'm just going to say, everybody knows what option is, right? Maybe in Haskell, everybody's comfortable with that? Good, nodding heads. So it's going to be very trivial. Read from standard input, turn that into an integer. That can fail, so some very complex try-catch logic around it, and there we go. I can read your input. Now, if we have that, now that I can read your input, I can handle a single guess. If I know the target number, then I'm going to return a Boolean, depending on whether or not you guessed correctly. If I'm going to read the input and pattern match on it, if you guessed the exact target, then I'm going to say true. If you guessed a valid number, but not the target, then I'm going to let you know whether you were too high or too low and return false. And if you somehow magically failed to enter an integer, I'm going to let you know and return false. Yeah, I know you can't read it at the bottom. It just says false. It's not the most interesting part of the talk. And usually the code stops much higher, so you should be fine. Okay, now that I know how to do one guess, I can do them all in a loop where, given a target number and the remaining number of attempts, I will let you know whether or not you guessed. And the code all but writes itself really. If you've guessed it, congratulations, return true. If you fail to guess it and no longer have any attempts, I'm going to print an encouraging message and return false. And otherwise, I'm going to let you know how many attempts you still have and return and keep looping. Again, you can't read the code, doesn't matter, it's Scala anyway, you wouldn't be able to read it. So that's a run loop. Once I have the loop, then I need to start the loop. So I need a run command. Again, return the same Boolean. Pull the number out of thin air, print instructions, and start the loop. Pretty simple, right? It's very straightforward. And for a long time, the Scala community was very happy with this kind of code. We solved problems, we shipped to production, and for a shining moment in time, we added value to shareholders. But then somebody made a dreadful mistake. Somebody said in public, where everybody could hear them, that Scala is a functional programming language. And that caught the attention of the Haskell people, some of whom might be here with us tonight. And the Haskell people, they have definite opinions on what is and isn't functional programming. And they said, that's not functional. That is not functional, I'll tell you why. That, if you call that function twice, that might return a different number each time. Now, that statement was met with some amount of confusion, because they thought that was rather the point of a random number generator, actually. But the Haskell people said, OK, maybe that was a bad example. Let me explain about side effects. Side effects happen when some bit of code relies on global mutable state, relies on or modifies it in a way that can only be observed at runtime. And the problem with that is since it can only be observed at runtime, then the compiler can help you, the type checker can help you. You have to keep everything in your head, and you have to sort of keep all the possible states and plan your move ahead and then run the program and hopefully observe the problem. I like to compare that to this absolute nightmare of a thing. I don't know if any of you enjoy these kind of things. If you do, seek help. I hate it. And the idea is all these colors are global state. And whenever I want to make a move and get closer to a solution, I've given up on actually solving that. My son might get it, but I'm trying to plan ahead. And if I twist that face with any luck, there's going to be some yellow that gets here. And yeah, that should work. And of course, when you do it in the end, well, there's some pick that got here. It's not exactly what I wanted. You don't need to look at the Rubik's Cube. I'm not even trying to solve it. It's just, it's just a gimmick. Are you all looking at it like, oh, he's going to solve it? No, I'm not. No, that's not going to happen. And there's even some purple. I didn't even know this had purple. I hate this thing. I absolutely hate it. It's a very good metaphor for software when you write it in imperative style, because when you think about how dreadful this is, suddenly the idea of bootstrapping an entire industry and theft of intellectual property and destroying the planet in order to automate the solving of it, well, suddenly it starts making sense, doesn't it? So no, we hate that. And so we answered to the Haskell people, I see how it's a problem, but surely that's a fact of life, isn't it? Surely this is what software is. And they answered, not so. Because what you can do, you can encode the effects in a type system. And so if the compiler is able to track the effects for you, then you start from this, and you turn it into something that's a lot more tractable. And I was actually going to try to solve that, but it's got messed up in my, I don't know if I can, oh yeah, okay, right. Let's pretend it didn't happen. Right, and this is a lot easier because you have far fewer states. The compiler tells you exactly all you have to handle, and I can plan my move ahead and actually solve this thing, right? It's a lot easier. Now, still not fun. It's still a Rubik's Cube. Anybody who tries to tell you that Rubik's Cube is fun is probably going to try to steer the conversation towards how they're part of Mensa and run away from that conversation. But with my clicker, now it's a lot more tractable. So we said to the Haskell people, that sounds brilliant. Tell us, enlighten us, how do we do that? And they said, with a smug little smile, well, us in the Haskell community, we use monads for that. Now, this is not to talk about monads. In fact, I'm talking about how not to use monads, so one could say it's the opposite of a talk about monads, but I do need to mention them a little. Because there's a variety of ways of encoding effects as monads. You could, for example, have one monad per effect, and if you multiple ones, stack them, which is going to look like something like that. And that's the MTL approach. It's maybe a little archaic. The UX is not great. It's Rubik's Cube kind of fun, but it works. It definitely works. You could also instead of having one monad per effect, decide on a set of effects that you reckon is going to be sufficient to write most programs, encode them in a single monad, and then invite Curtis Yarvin to keynote a conference twice. It's a really popular approach in the Scala community. We seem to love that. Better way could be, for example, to have a single monad with interesting constraints, expressed here as type classes, but there's other ways of expressing it. What else could we do? Well, you could, of course, use free. Well, that works quite well. So there's plenty of ways of doing it. I don't know them all, and I'm a master of none, so I'm not going to explain how they work. I am going, however, to mention that they all suffer from two problems. See, with monads, you're tracking your values inside of a monad. So in order to work with them, there's some ceremony, some theatrics involved with getting access to the value and working with them. So to give you an example here, this is how you add two values without monads, and this is how you do it with monads. It's not much harder, but it is harder. There's some cognitive and syntactic cost to using monads. Another problem that we have is you're essentially going to bisect your standard library. You're going to have to write two versions of a lot of combinators, one for monadic values and one for non-monadic values. There's a lot of examples, filter M, map N. I have traverse M here. See, Scala is beautiful. But yeah, you end up having to have multiple versions of the same combinator, which is not the end of the word, but it is annoying, isn't it? So where did I want to go with this? Right, yes. So these two flaws, they're drawbacks, but they're not showstoppers. We've not let that stop us anyway, right? The Scala community has fully embraced that. Everybody and their brother has written some form of library for categorical abstractions. I have, it's rubbish, don't use it. But everybody has and everybody uses them. We love it. We love it so much that there was at some point some pressure on Martin Ardesky, the creator of the language, to make them part of the standard library. And Martin is notoriously open-minded about these kind of things, so he gave it a long, hard thought, I think a solid 5 seconds at least, and said, he turned around and looked upon the assembled congregation of developers, gazing adoringly up to him, and told them, I'm going to paraphrase somewhat. He said, verily, verily, I say unto thee, that is some bullshit. Traverse is always the answer. What? No, not in my language. I'm not having that. And that's the end of it. This is not part of Scala. It's never going to be part of Scala. But he's not entirely unreasonable, and he realizes that having effects tracked in a type system was a useful thing to have. And so he came up with a counter-proposal, where I use proposal in the sense of, if you don't like it, you can suck it, kind of meaning. And he told us, right, what we're going to do is this. What if an effectful computation that returns a Boolean were to return a Boolean? And it's a bit crazy, but bear with me. We've not encoded anything in the type system yet. But what if we said that we needed to pass the ability to run these effects as functions, parameters to a function, right? That's simple and easy. And it's encoded in the type system. So that's what we wanted to do. And some of you, probably the same one who earlier went, that looks like imperative code, are probably now thinking, well, that looks like dependency injection. And yes, very well done. You're very bright. This is exactly dependency injection. Now, some of you do Scala, apparently. In a Scala community, we have a pattern for dependency injection. See, we have this weird quirk. Apparently, as a community, we hate passing arguments to functions. Nobody's too sure why. I think this all runs on JVM, so I think deep inside we all yearn for Spring Boot. So we don't quote me on it, but I think that might be the reason. And so we have dedicated a large chunk of the language into the ecosystem to not passing arguments to functions. We call that implicits or givens. And they're really the poor man's macro, right? What happens in the compiler if it finds a hole of a shape and a single value, a single peg of the right shape, it's going to put the peg in the hole. That's it, right? So there's nothing magic about it, but we love them. And in order to use that, we're going to transform this, the fat arrow, which means a function, to, I don't know how to call that. I'm going to say the slightly confused fat arrow. And that means a context function. A context function is like a function, but all the parameters are implicit. Lo and behold, capabilities were born. Now, before we actually write one, what have we seen so far? We've seen that we want to track effect in types. That's interesting, that's lovely. Monads are a practical solution with some drawbacks. Capabilities might be another without these drawbacks. But Obviously, there might be some others, and not to spoil it or anything, but clearly there's going to be some other drawbacks. It's always a matter of trade-off, isn't it? So if we're all clear on that, we can move on to writing our first capability for random numbers. See here, we pull a random number out of thin air, and really that's relying on the system clock. So it's relying on time. Time is eminently mutable. It changes all the time. That's what time does. So we need to encode that as a capability. And we said in order to do that, we need a type. So here's our type, rand. It's got a single operation, next int, which given an upper boundary, is going to generate a number between 0 and that. And that's it. That's your capability. Now we're going to, and return an int, yeah. Now we're going to update our function because we said if you wanted to use a capability, it needed to come as an implicit parameter to a context function. So that's updating the types. Of course, we need to update the terms, and now we need to use R. And that solves the problem, doesn't it? We're using the capability. Everything is encoded in the types. We're passing the ability to do random numbers. That solves the problem. I hate it. I hate it because of this. I told you we are going to try to have the code exactly the same as before, and that's different. So let's try to get rid of that. But the first thing, well, that's quite easy. That's applying a method on an object, right? And that's just fancy passing an object to a function, and we don't like to do that, right? This is Scala, remember? We don't do that by hand. The compiler does it for us. So we're going to make R implicit by creating this helper function, nextInt, which returns a context rand to int, and the implementation is trivial. And you might say, well, that's exactly the code you just said you hate it. Yes, I hate for you to write it, but I, as a library author, I want to write it once, so you never have to. And then, based on that, you can write range. I'm never using the rand capability here explicitly, or lower car, or upper car, right? Never do I have to use the capability explicitly because that's already been handled in nextInt. Now, I could write a bunch of these. I have, in fact, written a bunch of these because this is the premises of a pretty cool property-based testing library, and it's a bit of a hobby of mine to write this. So if you don't stop me, I'm going to spend the rest of the talk talking about property-based testing. Let's not do that. Let's instead fix that. Now that works. That works in compile. Can you see why it shouldn't? What's the type of nextInt? It's rand to int, isn't it? So presumably, target's type is also rand to int. Target then is rand to it, and passing it to something that is an int. Right? Loop expects an int. So that shouldn't compile, but it does. It does because of an interesting property of context functions. They're eagerly applied. So as far as the compiler is concerned, this is actually syntactic sugar for that. Which you may think, well, you should love that, Nicolas, because this is exactly how you manage to keep your word of making the term code, the code from the code that you're writing exactly the same as the code that we had in the beginning. And yeah, in theory, I should like it. In practice, it's a little weird, right? Because the compiler will transform computations to values and values to computations. We're going to see that it does the other thing as well. And so, this is exactly what we have been taught by languages like Frank not to do. We want to have a clear demarcation between computations and values. And Scala blurs the two. So I think it's debatable whether there's a good design choice, but that's what's happened. And now we're going to see the other way around by trying to get rid of that. I don't like that because why do I even have to name R? I never use it anywhere, right? Why do I need it? So what I want to do, I want to get rid of it. Do you want to see some magic? That's it. That works. Magic. It's not magic. You're too gullible. What's happening here is a very simple process which is called automatic conversion to context function. Now that's a bit of a mouthful. So I'm going to call it that on top, ACF. I'm actually going to verb it. So we are ACFing here. What's going on is that the compiler, when it spots this, which returns a Boolean, right? So when it spots a Boolean, where a context function to Boolean is expected, is going to generate that code. And the two are exactly equivalent. So this is where the compiler is turning a value into a computation. I don't like that either. Again, blurring the distinction between being and doing, it's not great, but that's the E Scala. Since we don't have to have that, we can just get rid of it. And that's exactly what I promised you we'd do. We change the code spot, the term level, is exactly the same as before, right? Of course, I've only shown you half of the equation because we take a rand. Somebody has to write that rand, don't they? So we're going to do that now. Now, the vocabulary gets a little tricky here. So this is what we have to write. System is called, I hate that it's called that, it's called a prompt. I hate that it's called that because whenever I say it, it makes me think of LLMs and I want to throw up a little. But that's what Martin wants to call them. And a prompt takes a computation and runs it to completion. It does so by providing a handler. And this is where it gets confusing because in other languages, system would be the handler. But in Scala, handler is a handler, which it's easy way to remember it. But the instance of the capability is a handler. And then writing the handler is trivial, right? It's going to use the standard random number generator and just proxy calls to it, and then run the computation to completion. It's pretty trivial. And so running a program is just that. You put run in scope of run.system, and it's going to run perfectly. And of course, I mean, you probably already know these things, but it's still nice to put them out there. You can write multiple handlers. So we could write a handler for testing purposes, say. I could want to always generate the same number so that it's easier to test. I could write const, which takes a number that's definitely not random, and runs the computation to completion by having a handler that always returns not random, right? And so now testing our game is just a matter of putting it in scope of the right handler. Of course, it's not a great test yet because it still has user interaction. Somebody has to type in the guess. So we're going to address that momentarily. But first, quick takeaway. Capabilities are implicit parameters. We usually manipulate them through atomic computations, the next int helper I showed you earlier. And concrete implementation handlers decide how they behave. I have no idea how much time I have left, and the person who is supposed to show me the papers is 15 minutes. Great. OK. Ooh, tight, but we'll make it. OK. So everything OK so far? Everything clear? No blocker? Good. All right. User interaction. If you look at that code, we still have that print line. That modifies the standard output. It's definitely effectful, so we didn't need to transform that into a capability. It's not going to be very hard. We just create print, the trait, and have a single operation, print line, which takes a string and returns unit because this is really nothing useful to return here. And we're going to do the, the helper that we talked about before, print line, which takes an any. And we can't do that in Scala because we run on JVM, and on JVM they decided that everything had a human readable representation. Presumably they did that before they'd heard of lambdas, but this is part of Scala, so we can use that. And the implementation is the obvious implementation, right? And now I have put print line in scope, so it's going to shadow the standard print line. And this is now my print line, and the compiler is going to complain that you're running an effectful computation that relies on print, but you don't have print. So we are going to update our signature. And so it's probably obvious, but it's worth saying we have effect safety in Scala, because the compiler will prevent you from calling an effectful operation if you don't have a handler in scope. It's worth pointing out that some languages don't. I'm thinking about OCaml, for example. Doesn't have it yet. They're working on it, if I understand correctly, although you seem to be a little dubious about their ability to do it. Xavier? Yes, that's a different language. Yeah. Anyway, where was I? Oh yeah, an interesting bit here. This is the first time we have a computation that takes two capabilities, and you might wonder, does the order matter? So let's quickly do that. Run swapped, which is basically a proxy for run, exactly the same type signature. What I'm going to do is I'm going to swap the capabilities, hence the name run swapped. And that's going to compile and run, which to me proves conclusively that the order doesn't matter. Now, the reason it works that way, it's not magic, it's ACFing again. Because what happens? Run is an effectful computation to Boolean. They're eagerly applied, so the compiler treats that as of type Boolean. It finds a Boolean where it expects a computation to Boolean, so it's going to insert that. And then the implicit resolver kicks in and finds a print and a ren where it expects them and just stick them in there, because the implicit resolver works with a single value, so the order doesn't matter. So initially, when I realized it worked, I thought, oh, there must be some magic there. No, it's just clever features interacting well together. I quite like that. See, I keep trashing on Scala, but I actually quite like it. This is clever. OK, so now we're going to have to propagate the capability because, again, effect safety, we have to have a handler everywhere we use an effectful computation. We use printline a bunch here, so we need to update loop. We use printline a bunch here, so we're going to need to update guess. And there's one last function that we haven't touched, which is read input. And that is very effectful. That reads from the standard input, so it relies on some global state. And when you read from the standard input, you drain the standard input, so it also modifies the standard input. So it's very effectful. We want to turn that into a capability called read. Single operation, read line, which returns a string, and the usual helper, read line. We've done that a bunch. We know how that works. And now, of course, this has shadowed the old one, so we're using mine. And we have to declare that it takes a read. And of course, that's going to percolate down the call stack, or up, whichever way you want to think about it. So guess calls read input takes a read, so of course we need to update it to take a read. Similarly, we need to do that at every layer until we get to run, which takes all three capabilities in order to be able to be executed. So almost finished. Now I just need to write a handler for read and for print. And I wanted to show you how you could provide a handler for two capabilities at the same time. How you could actually create a capability that was the aggregation that composed two other capabilities. Here, TTY, because read and print is really just a TTY, which extends prints and reads. I'm not declaring any operation here. We could have, for example, NC color handling. I'm not doing that because there's a lot of NC colors and I don't have room enough on the slides, but you could. And then a handler for TTY. Takes a computation, runs it by providing a handler that's just a proxy to the standard console, right? And then you run the computation. Now, we could decide, we started writing a test earlier, we could finish that, so we could write test handlers for print and read. Yeah, sorry, this is how you run the program. You just add TTY so that the handler is in scope. Now, what's a test handler for print? The only reasonable thing to do is to write to dev null, isn't it? So we're going to do that, ignore, which has a handler that basically ignores its parameter. And then we run the computation. And for read, well, I want to be able to control what the user has typed, so I'm going to do basically the same thing I did for random numbers. I'm going to take a string that's not random. And then my handler is just going to return that all the time before running the computation. And so I can test my software now by saying, I'm going to ignore the prints. I'm always going to generate 5 and read 5. And then that should always return true. And some of you, the aesthetes around you, the person with fine taste, my kind of people, are probably thinking, that looks a lot like a property. And yeah, if we had a property-based testing library, this would be a fine property to run. I think I'm done. Yep, in closing, if you only remember just one slide, capabilities are dependency injection, really. That's all they are. They allow direct self-programming, which means not using monads, which I quite like. And we encode effects in types. So basically what I promised you we'd do at the beginning, right? We are going to be in a direct style. We wrote the same program. We just changed the types, but the program is exactly the same. Everything I promised to deliver, which was not that much, but I delivered all of it. So that is nice. And before I open the floor for questions, I'm going to try to preempt a couple. Because usually when I explain all these things, I get the, yeah, I'm fine. This is just the end of the conclusion. The questions I often get are, first, I said this was still being actively researched. Did I say that? I should have said that. If I haven't said it, I should have said it, pretend I have said it. And it looks like it's not being researched much because everything I've shown you are features that have been part of Scala for years. So this part of capabilities is not under active research. What is what we call capture checking, because if you've seen my handlers, the useful ones are all very stateful, and the state they might carry might be a resource, for example, something that is closed at some point. So, for example, in scope of your prompt, the prompt might close the resource by the time it returns, and you might, if you allow effectful computation to capture the handler or to lazily evaluate it, then it might be evaluated after the resource has been closed, and that's problematic because it hasn't defined behavior. And so capture checking is something that is actively being researched, which is quite fun to play with, although it's so actively researched that whenever I try to compile code that I wrote yesterday, it stops compiling because they keep changing it. It's a bit annoying. But the way it works is you decorate types with the bindings of the capture, And then the one that you're interested in, the compiler is going to be able to say, well, this one is escaping, and you're not supposed to do that, and fail compilation. It's really quite interesting. I said that I was going to talk about the drawbacks of this approach. I haven't, so quickly, the first drawback, which is more linked to direct style than capabilities, but direct style loses you referential transparency, or the assumption of it. Now, I was absolutely convinced of that this morning, then Xavier happened. I'm not so sure any longer. So I see you smirking. I still think it's true. We lose referential transparency. Referential transparency, we might debate whether it's a terrible loss or not. We might debate whether it's worth what we gain by losing it. That's a question of opinion. But however, when you have it, it's very nice to have, and I think we lose it. And I think another thing that we lose is with capabilities and effects in general, you sequence operation, you create dependencies between computations, so you can very easily do monadic style. You cannot very easily do applicative, or if you can, I don't know how. As if Xavier is smirking again, so I'm guessing he knows, but I don't. So you lose these things. You lose some things that come with monads, which are really nice. You do also get much clearer code, which I like. And the last thing is, yeah, some of you are probably thinking, well, that looks a lot like algebraic effects, everything you showed us. Yes, no, they're not algebraic. So there's two things about that. There's a debate whether or not this is algebraic effects. Some people think not. I'm going to call them user-defined effects, and everybody's going to be happy. And I don't think if there are user-defined effects, they are very limited ones, because if you know the literature a little, in user-defined effects, your handlers have access to the continuation. That represents the rest of the program, right? Hey, we don't have that. There's no continuation, which means that we cannot implement non-local control flows that are not already supported by the system. So for example, we can't do backtracking. We can't do coroutines. We can't do generators, these kind of things. Now, it's very limiting, but it's only limiting you to what your host language doesn't already support. And in Scala, we already have errors with exceptions. We already have asynchrony. Is that a word? Let's say it's a word. Asynchrony with Loom. We have everything we need to do what Scala developers do, which is essentially web services. So it is limiting. It is a shame. I really wish we had more, but we have enough. And also, they're apparently currently researching how to implement single-shot continuation, which would allow us to write most of the control effects, but it's still actively being researched. I don't know where that's going. And I think that's it. Yeah, if you have any questions, now is the time. Thank you.
Thanks a lot. I'm not very familiar with Scala, but I have a question related to the name capability.
Yes.
Is the name related to the fact that, because I'm pretty sure that Scala is implicit for years now, as you said, and so capabilities, it's a new name for dictionary passing style, or it's obviously attached to capture checking?
So, it's not technically attached to capture checking. Capture checking solves one problem, capability is another, capabilities are just implicit. Now, used together, I think what LAMP does is use together the defined capabilities. But yes, there are two separate sets of features that when you bring them together, then you get capability. They call it capability passing style, which I hate. I mean, that's going to be CPS. But yes, so yes, there are two separate features, and if you take them together, then you get capabilities.
Okay, thanks.
You're welcome. Any further question? Yes?
You showed, or you said that the definition side, the order of the effects doesn't matter.
Yep.
But how does it work when you have the system call, or when you define your handlers? Because you showed that basically the effects get put together in whatever arity function.
Yeah.
And when you call the function, basically when you free up, you have to have some kind of decarrying happening automatically, or how does it work that the handlers, you provide three handlers? With the test example, for example, print ignore provides the print capability. Then you have the next capability. So you basically provide three capabilities, one after the other, but the run method expects one three-arity function.
No, no, it does. but I showed earlier with acting, the order doesn't matter because run, here's a boolean, so this is going to be expected. So run returns a boolean, assert.
You showed the definition side, not the call side. This is the call side now.
This is the call side, yeah. Oh, you wanted me to show you the definition side?
No, you showed on the definition side, the order doesn't matter.
Right.
That's clear.
At the call side.
The question is, how does it work here? Because we have here three
right.
context functions,
Okay, so
right?
run has 3 implicit calls. One for run, one for print, and one for read.
Okay.
And ignore prints one print shaped spec in scope. Run prints one run shaped spec in scope, and read.
So it's basically 3 or 4 parameter lists.
No, there's no list. That's implicit values in scope, and then run takes 3 parameters that the implicit resolver is going to resolve for you. And since there's no ambiguity, because you have a single run, and a single print, then the implicit resolver goes, okay, that goes here, that goes here, that goes here, fine.
Okay.
Right? There's no magic, and that works. Now, the question is interesting because sometimes you do have dependency, an order in your effect. So, for example, you might have asynchrony and error handling, and you have to handle the asynchrony before the error handling because the way it doesn't make sense. But the way you do that is by having a context function that returns a context function that returns the value. And then the order of handler matters, right? Then the order of providing them matters. But in this very simple example, it does. I think, yes?
Yeah, I wanted to ask if there are cases where it's not possible to infer like what to put in the implicit argument.
Yes, if there's no implicit in scope, or if there's more than one.
Okay, yeah. So if I did 2 reads, for example, it wouldn't know.
The compiler would tell you, well, there's 2 of them, and I only have one. I don't know which one to pick. You have to tell me.
No.
Otherwise, it would be insane, wouldn't it? I mean, more insane. Any other question? Yes?
I've heard something about error handling in Scala using capabilities, like that you don't have, where you can safer exception handling in a direct style, also using capabilities. Do you know what the state of that is?
Yeah, that's working. That's part of the standard library now. It's clever. It's also a little disappointing in my opinion because it relies on modifying the language. So it's not a library. They modify the language slightly to have when you have a handler for exceptions, that modifies the code in a weird way. It's very elegant, it's very good, but it modifies the language a little bit, so that's a little disappointing.
That's specifically for exception handling, the modifications.
Yes. You could also write a fail capability that is purely at the library level, works quite well. It just requires that you can't use the syntax for try-catch. You have to come up with your own syntax. And of course, you have a problem with that. Most languages that have user-defined effects suffer from a problem which is called effect pollution, where you might end up handling an effect you shouldn't handle. Now this happens because because handler are dynamically scoped in most languages. Can't happen in Scala, because in Scala they're statically scoped because they're parameters to functions, right? So we don't have that, except in one specific case, exceptions. So if you use exception, in order to implement something like a fail capability, then you suffer from effect pollution.
Because it's always the same exception
yes.
that you're, even if,
So the problem is, if you throw an exception of a given type, and somebody, the effectful computation just blank catches everything, then it's going to catch a message you're sending to yourself and not allow you to get it.
Right, because even if they're 2 separate handlers, your exception is the same.
Exactly, so you get a problem. I think somebody was desperately raising their hand 3 times already in the back. Yes?
Do I understand correctly that all these implicit parameters compile down to actual function parameters? So if you have
yes.
10 effects, then all your functions are going to take quite
The
parameters.
The question, let me rephrase that, A for the mic, B for the people in the front who don't have my keen ear. You ask whether it was true that compile times the implicit were resolved and just turned into regular parameters to functions. That's your question, right?
Yeah, and just that at some point become a performance issue when you have 10 effects and all your functions take the whole function.
So yes, it works exactly like that, and does it ever become an issue because you have too many parameters? Well, yes and no. You can have any number of parameters you want for functions in Scala, so long as it's less than 22, which is purely arbitrary, but that's I'm sorry, I'm working with what I have here. Did that answer the question?
Okay, so that does come up.
It's, if you have 23 capabilities, then yes. Yes?
Since scalability are in covariant position, should we not talk about co-effect?
Maybe you should. Go ahead. I'm not qualified to talk about it. I'm not even sure what a co-effect is. So I'm just going to look at the listener here and say, no, I know that question came from you.
No.
Yeah. I think I should wrap up. Oh, so a few minutes. Great.
3 more minutes.
Great. 3 more minutes. At least one question. If there's any more questions. Guess not. Thank you very much for attending.
Yeah, I have a last question.
Oh, no.
What's your sentiment towards Rubik's cubes? Do you like them or do you hate them?
Depends. I quite like the small one, because that one I can do. This fucking thing, though.
Okay, I got that from the talk. Yeah, thank you very much.
You're welcome.